So just like the previous class, in each class you will be having some class assignment or class performance, which is basically during the class I'll probably ask you to write the algorithm, because it would be difficult for you to write the program as well as for me to check during the class. So you can write the algorithm, okay, and you can while the class is going on, you can also upload it to the classroom. I'll create the link and you can upload. So that would be one part of your evaluation. The other part, that would be one part of your continuous evaluation. The other part would be the home assignment, just like the previous class, where probably for the same problem, I would ask you to write a program for it. Now, now the thing is, whether it is your class performance or it is your assignment, okay, you are supposed to do it on your own. And if you need any help, you can revert back to me, okay. Of course, I would expect you to be able to write program or algorithm, but if you need any help with the problem itself, okay, that I can do. Okay, so that you can either send me an email or you can, post your concern in the classroom. That is fine. But if I find that two or more of you are submitting essentially the same program, as of last assignment, I have given you some marks.
সেম প্রোগ্রাম তো হতে পারে স্যার।
না, সেম প্রোগ্রাম হতে পারে না, সেম প্রোগ্রাম হতে পারে না। সেম প্রোগ্রাম কেন হতে পারে না? স্টার্ট each and every syntax, each and every punctuation and everything cannot be same, okay. And you can trick a teacher in that. By looking at a program, the teacher knows which one has been copied multiple times, okay. এবং সেটা যদি হয়, if you let your friends copy from you or you copy from someone else, last assignment of the I've given you some marks, but next assignment onwards you'll get 0, okay. It should be your program. The basic structure might be similar, might be but if it is the same program, that we would know. If there is a same mistake in the or same type of symbols has been used for same quantities and all, so that there are ways to figure out which one is the same program, which two are same program. So the point is you should do your own work.
বলতে ক্লাসের মাঝে স্যার দিচ্ছেন এগুলো, স্যার মাঝে মাঝে কি হয় বলুন তো, আপনি দিচ্ছেন ওটা একটু for due to some network issue have not uploaded correctly. So last day it was raining here and the assignment was not uploaded at fast. I have to try 3 or 4 times for the uploading. Sir, some network issues are
network issue. Okay, so I can understand the network issue, and maybe on the first trial you are not able to upload, and then you can try later, right? So otherwise there is I also cannot help you if you cannot upload, okay. But you have an entire week to submit your assignment, so I don't see the problem there.
না স্যার, আমরা ক্লাস অ্যাসাইনমেন্টের কথা বলছি,
ক্লাস পারফরম্যান্সের কথা বলছি। So class performance, what I can do is I can at best give you another hour after the class.
আচ্ছা, ঠিক আছে, ঠিক আছে।
So once the class is over, you can have another hour. In that time, you can upload your class assignment. Okay. Now, before starting a new topic, what we discussed in the last class was least square curve fitting, and
Hello, sir. Hello. হ্যাঁ, বলছি আমাদের না স্যাটারডে করে প্রবলেম হয়ে যাচ্ছে এই সময় সেশনে, সবারই আমরা সেদিনকে মিটিং করেছিলাম, তো সবাই বলেছে মোটামুটি স্যাটারডে আর উইকেন্ডে আমাদের অ্যাসাইনমেন্ট কমপ্লিট করা, মানে বাকি কাজগুলো তো করতে হয়, তারপর এক্সট্রা।
একটা জিনিস বলি, by all means I would like to take the class at the scheduled class time. Problem is, yesterday I had to visit university. Okay, so there would be some official work for me, being being a teacher as well as a section in charge of applied mechanics specialization. I'll be having some meeting to attend, except for those days. I'm not hoping many of them would happen. I would try my best to take the class at a scheduled time. Also, the problem is with the class timing is that once I start taking this class, I will not be able to visit the university on that day. And that too, I was prepared to do that yesterday.
কোনো দিনে ক্লাসটা ফেলতে পারেন, তো আমরা তো আপনাকে অপশন দিয়েছি। আই থিংক কিংশু আপনাকে মেসেজ কনভে করেছে।
ওকে, লেট মি ফিনিশ।
কিংশু তুই যেটা বল আরেকবার।
আমি কথাটা বলে নি। Okay, so now I'm okay, even okay with, I was even prepared to take the class from 11. Okay, but if you say that you cannot do the class from 11, if you want to do 11:30, okay, then that would be a problem. In that case, I will not be able to finish it by 2. It will take 2:30, and after that, there is no way for me to do any other work. So that would be a problem. Number 2 is regarding any other option. Problem is I have other classes too. Okay, and মানে অপশন দিলেই সেটাকে অ্যাকোমোডেট করা সম্ভব হবে না। I visit more 2 or 3 days. I visit the university 2 or 3 days in a given way. তো আমার পক্ষে সেগুলো অ্যাকোমোডেট করা সম্ভব হবে না। I prefer যেটা তোমাদেরও রুটিনে স্পেসিফাইড টাইমিং, ওকে, and I prefer the scheduled time. If anything is I prefer that would be the scheduled time. So next day onwards, I'll try to take the class on the scheduled class time. Okay.
স্যার, ইন কেস আপনার যদি কোনো অসুবিধা হয় আপনি সোমবার আর মঙ্গলবার নিতে পারেন স্যার। ওই আমি আপনাকে টাইমিংটা লিখে দিয়েছি, তো আপনি সেরকম যদি আপনার যদি স্লট থাকে লাইক 2:30 to 5:30 ওরকম টাইমে আমরা অ্যাভেলেবল আছি স্যার।
Okay, so that we can talk later. Regarding
সত্যি বলতে কোনো রাগ ভাগ না করে বলছি স্যার, যে অ্যাকচুয়ালি স্যাটারডেতে আমরা লাইক ক্লাস আমরা অ্যাকচুয়ালি প্রেফার করি না একদমই, বিকজ আপনি অলরেডি অনেকবার পয়েন্টগুলো মেনশন করেছে বিকজ ওয়াই আমরা প্রেফার করি না। তো একটু আপনি যদি একটু আলোচনা করেন ব্যাপারটা নিয়ে, তো খুব ভালো হয় আর কি। আমার একটা কনস্ট্যান্ট একটা সলিউশন আমাদের আসা উচিত, রাদার দেন আই মিন লাইক যে কোনো উইকই প্রবলেম হতে পারে, লাইক প্রবলেমটা অলওয়েজ আমরা কনসিডার করি।
মানে এইটা বলতে চাই যে মানে আমরা মানে কনসিডার করি স্যার, কিন্তু আগের সেমিস্টার কি হয়েছে বলুন তো, আগের সেমিস্টারে আমরা মানে শনিবার দিনকে এরকম করেছি। এবার অনেক স্যাররাতে এক্সট্রা ক্লাস নিতে চান, অনেক সময় সিলেবাস শেষ হতে পারে না, তো আমরা সেই কারণে এক্সট্রা ক্লাসগুলো ওই সময় ফেলেছি আর থিওরি ক্লাসগুলো ওই সময় ফেলেছি। এবার পুরো মেস আপ হয়ে গেছে ব্যাপারটা আগের সেমিস্টারে, তো সেই কারণে আমরা সব সিআর মিলে, তারপর যারা অফিসিয়ালে আছে তারা পুরো পুরো মেক ডিপার্টমেন্ট সিদ্ধান্ত নেওয়া হয়েছে যে উইকেন্ডে আমরা মানে যতটা পারবো ফাঁকা রাখবো, যদি কোনো এক্সট্রা ক্লাস শিফট করার দরকার পড়েও বা আমরা তখন উইকেন্ডে দিয়ে দেবো। তো সেই কারণে আমি একটুখানি বলতে চাইছি যদি একটু কনসিডার করেন স্যার প্লিজ।
ইয়েস স্যার।
ওকে, এবার একটা জিনিস ক্লিয়ারলি বলো, তোমরা কি আজকে ক্লাসটা করতে চাও না করতে চাও না?
হ্যাঁ স্যার, আজকে ক্লাস করতে চাই, অবভিয়াসলি আজকে ক্লাসটা করতে চাই।
তো সেই ক্ষেত্রে আমরা অবভিয়াসলি করবো স্যার, মানে ফ্রম লাইক নেক্সট উইকে একটা আমরা একটা কনস্ট্যান্ট একটা ওয়েতে যেতে চাই আর কি। তাদের মানে শিফটিং এর প্রবলেম হচ্ছে আর কি। আমার নিজের আজকে একটা অন্য জায়গায় যাওয়ার ছিল, বাট আমি সেই প্ল্যানটা ক্যান্সেল করেছি ফর অ্যাটেন্ডিং দিস ক্লাস অ্যাকচুয়ালি। তো লাইক আমি মিস করতে চাই না ক্লাসটা অবভিয়াসলি, বাট দ্য থিং ইজ লাইক আপনার হয়তো ব্যাপারটা আমি বোঝাতে পেরেছি অলরেডি। আপনি একটু প্লিজ দেখুন স্যার যদি পসিবল হয়।
Sorry?
Sir, actually the on-class evaluation, sir, many people had uploaded the document properly, but due to some technical reasons, it had not be somehow shows in your screen or something. So many people had got the marks on the on-class evaluation process.
Okay. তো আমি তো কারা মার্কস পেয়েছে সেটা শেয়ার করেছি। ওকে, তো কাদেরটা আমি ডকুমেন্টগুলো পেয়েছি সেই অনুযায়ী আমি এভালুয়েট করেছি, ঠিক আছে? মানে আমি যে সময় পাঠিয়েছি সেই সময় পর্যন্ত আর কি। এবার সেটা দেখে তো নিশ্চয়ই আইডিয়া করতে পারছো যে কার কার আপলোড হয়নি। তো তারা তারা সেটা আমাকে ক্লাসরুমে জানাতে পারো।
হ্যাঁ স্যার, জানিয়েছি আপনাকে।
হ্যাঁ, আমার ধারণা আমি ইনফ্যাক্ট পরে তুমি বোধহয় আপলোড করেছো সেটা আমি চেকও করেছি, কিন্তু সেটা খুব সম্ভবত in the afternoon, somewhere in the sometime in the afternoon.
Yes, sir.
ওকে, তো এটা জানানোর পারপাসটাই তো এটা যে তোমরা যাতে বুঝতে পারো কার কারটা আপলোডেড হয়েছে।
স্যার স্যার আই ওয়ান্ট টু টেল
হ্যাঁ বলো।
স্যার, আমি তো আগের ক্লাস ডেটে আমি ছিলাম না, অ্যাকচুয়ালি আমার মায়ের ভ্যাকসিনের জন্য আমাকে যেতে হয়েছিল।
হ্যাঁ।
তো আপনি তো ক্লাস পারফরমেন্সের ওপর বেস করে 5 মার্কস রেখেছেন, তো আমি তো ক্লাসে অ্যাবসেন্ট ছিলাম, তো ওই আমি কি হবে আমার?
দেখো, একটা ক্লাস যেটা আমাদের মানে যখন আমাদের ফিজিক্যাল মোডেও ক্লাস হয়, তুমি একটা ক্লাস মিস করলে সেই ক্লাসের অ্যাসাইনমেন্টটা দিতে পারলে না, সেই ক্লাসের পারফরমেন্সের যেটুকু মার্কস মানে সেটা হয়তো সাধারণত বাদই যায়। তবে তুমি যদি মনে করো যে সেটা সেটা খুব জরুরি, তাহলে ইন দ্যাট কেস ইউ ক্যান মানে যেহেতু তুমি ছিলে না সেই সময় এবং আগে থেকে জানিয়েছো, you can also prepare the assignment and upload.
Oh, okay, sir.
স্যার আপনি কি কিছু প্রেজেন্ট করছেন এখন?
প্রেজেন্ট এখনো কিছু করিনি বা কিছু লিখিনি, একটা স্ক্রিন
আচ্ছা,
শেয়ার
আচ্ছা,
করা
ঠিক
আছে।
হ্যাঁ, নাও ইট ইজ ভিজিবল।
অ্যাকচুয়ালি ব্ল্যাক স্ক্রিন হয়ে গেছিল স্যার, তাই জন্য। আচ্ছা ঠিক আছে।
ওটা বোধহয়
এখন
উইন্ডোটা
দেখা
মিনিমাইজ
যাচ্ছে।
করার জন্য।
স্যার বলছি তাহলে আজকে ক্লাসটা আমরা শুরু করি স্যার, অলরেডি অনেক টাইম চলে গেছে।
হ্যাঁ, that I want by all means. So okay, so before that আচ্ছা, এখন অবধি কি এমন কেউ আছো, আমি একটু বলে দিই কার কার অ্যাসাইনমেন্ট আমি পেয়েছি, রোল নাম্বারগুলো। যদি কেউ বাদ থাকো তাহলে প্লিজ একটু জানাও। রোল নাম্বার 186, 187, 189, 190, 192, 195, 196, 197, 198, 199, 200, 201, 2, 3, 4, 5, 8, 9, and readmission 138. আমি আশা করছি এর মধ্যে
রিঅ্যাডমিশনটা কত বললেন?
হ্যাঁ,
রিঅ্যাডমিশনটা কত বললেন?
138।
ওকে স্যার, ডান।
Okay. So I have a few things to discuss about curve fitting. So we talked about fitting a straight line, and the means by which we did that was least square method. And in least square method, what we would be trying to do is to minimize the least squared error, basically sum of squared errors. So basically yi minus fi, where fi would be our desired function of x, desired functions of xi. So we wanted to minimize this quantity. And for least square method, we define certain correlation coefficient. So that was this quantity, not r squared. That is actually r. and that would be covariant of xy divided by
sigma of x and sigma of y.
Sigma x and sigma y.
Hmm.
Now, what we learned about this correlation coefficient was that when indeed x and y follow a linear trend, where indeed y is a linear function of x, this covariant of this covariant of x is covariant of x and y is essentially the product of sigma x and sigma y, or in other words, this correlation coefficient becomes either plus or minus 1 when indeed the relationship is linear. That of course depends on whether the slope of the straight line is positive or negative. So in this case it would be 1, and in this case it would be minus 1. Given that all the points with coordinates x and y lie on these two lines. Now, what I want to discuss today is when you are trying to do a different type of fit, when you are trying to do any other polynomial fit. So a straight line fit is the simplest polynomial. If you are trying to fit any other polynomial, for example, let's say a quadratic or a cubic polynomial. So we learned the process goes like this. So so essentially you need to define this A matrix, which is 1 xi squared up to one x1 squared and x1 to the power m. If you're trying to fit mth order polynomial, you would be having 1 plus m terms, which goes from x to the power 0 to x to the power m. And then there is 1 xi squared up to xi to the power m, and this continues up to xn. Okay, and then you have the coefficient vector. These are actually the unknowns, which goes from c0 c1 up to cm. And you have n such equations. So this is a n cross m plus 1 matrix, m plus 1 cross 1 vector. And the equation is something like this: A times c hat equals y hat, where y hat are you are trying to find a relation which is something like this. Now y hat is y1 to yn. Now if indeed n equals m plus 1, in that case A is a square matrix, and you can directly invert this matrix, or you can solve the set of equations and find out the coefficient c0 to cm. Now if you typically m would be much smaller compared to n, or n minus 1. Maybe you are working with 100 points, but m is let's say 5. You want to fit a fifth order polynomial with the 100 points that you have available, 100 data points. So n basically represents the number of data points xi, yi. So what you do instead is use something called a pseudo inverse, and we showed that pseudo inverse is basically A transpose A inverse A transpose. Okay, and we also showed that this use of pseudo inverse. So what we basically do is we get C as A inverse pseudo times y hat, and from that we get the best fit coefficients. So the functional relationship is established. So all we need to determine are the coefficients, and that we can do, that we can get the best fit ones by using the pseudo inverse. One other, so what we showed also, that this pseudo inverse is not random actually. this only comes from the least square error. Okay, and we try to define the least square error for polynomial fit, and from that we showed that this is essentially what we get. So all we have to do is to solve this equation: A transpose A times C hat equals A transpose Y hat, and in that we used okay. So we used one of the identities. For example, over here, we use this identity that A transpose A equals the inverse of A transpose A is essentially A inverse A transpose inverse. Now that can also be shown that if you multiply AB, let's say the product of two matrices, okay, not necessarily square. If I multiply, okay, no, sorry, each of them are square matrices. Now if I multiply B inverse A inverse, so we know that these two would give us an identity matrix, and later I times
this would again result in an identity matrix I.
Sorry?
Yes, so B into B inverse means I, and then I into A inverse. It would be again A inverse and A.
Yes, this would be an identity matrix. Now, one thing about inverse is that if you are dealing with square matrices, and if inverse indeed exists, the point is when the determinant is non-zero, that's when the inverse exists. And when the inverse exists, so then that inverse is also unique. But with the point being that this is essentially, it has to be the inverse of AB. And it can be shown that for any negative power, this relation holds. So if you are doing like inverse squared, A transpose A minus 2, there also this thing works. Okay. Achha. Now, this part is clear, but then how do you define a correlation coefficient, or at all that that the type of curve that you are fitting through your data, is it related? I mean, are the data points related in that way? Okay. Now the data points could be practically random. Okay. No correlation at all. Okay. Now the Pearson's correlation coefficient that we just used, okay, that can only predict the correlation when the correlation is of linear type. If you're trying to predict a different type of correlation, if you are trying to predict the correlation wherein the input and the output variables could be polynomial, then you cannot use this, I mean polynomial of higher order, then you cannot use this correlation coefficient. So in that case, what you can do is you can define two quantities. Number one is, of course, our squared sum error. Okay, and please remember this R also goes from -1 to 1. Okay. So this is one quantity. So list the squared sum, and this quantity right here, n times sigma y, which is summation over yi minus y bar squared. Okay, and one can define. So this one is called coefficient of determination. And that is 1 minus this delta squared divided by n times sigma y. Of course, if your fit is perfect, then this error squared would be 0. I mean, let's say you are trying to fit a parabola out of the data point and the points indeed belong to a parabola, then this error for each and every term should be 0, and essentially the squared sum of the errors would also be 0. Okay. So obviously in that case, this r squared value would be equal to 1 when there is a perfect fit. Okay. So this r squared value can only range between 0 and 1. Now, in which case it would be 1 when the points bear absolutely no correlation. Okay. I mean, y can have any value at any given x. In such a situation, if you try to minimize the error, so what you get as f is simply equals y bar. So we are trying to fit f of this nature, let's say c0 plus c1x plus c2x squared, okay, or maybe even higher powers. Okay, so all the terms that are dependent on x, they become 0, and c0 assumes the value of y bar. Okay, and if you substitute this expression, if you substitute for fi as y bar, essentially what you get is these two quantities are same, the numerator and denominator. So in that case, the r squared value becomes 0. So these are the two extremes. Okay. Now,
so would you please repeat what happens when r square equals to 1? Means what is the condition when r square equals to 1?
That is a perfect correlation. That is the perfect fit. Let's say you are trying to fit a parabola through the data points that you have been provided, and those data points, those y values at those given x's, they exactly fall on a parabola. In that situation, it becomes what would happen? The error, it would get the perfect fit, right? So the fi values would be exactly same as yi values. You are trying to minimize the error, and if the actual y values are parabolic functions of x, what would be the minimization of error when you are trying to fit a parabola? The f would be also the same parabola. See, y is the, let's say, the experimental data point or the real life data through which you are trying to fit a curve. And let's say by some means, okay, some hypothetical situation where yi is a certain function of x, and you are also using that type of function of x, let's say a parabolic function, you are also using a parabolic functional form to fit through the xy data. Okay. And if the two functional forms match, then you get an exact fit and you get a 0 error. And when you get a 0 error, then you get r squared value equals 1.
Yes, sir.
Okay. So that is all I wanted to cover. আরেকটা জিনিস বলে দিই যে এখনো অবধি যদিও আমরা ফিটিং অফ higher order polynomial নিয়ে ডিসকাস করেছি in length actually, and also we have now to discuss about the coefficient of determination or correlation coefficient and other things. So you are only being given the fitting of a straight line as an assignment. Okay. So because this deals with solution of a system of linear equations. Okay. So that's what we would learn today. Okay. আচ্ছা, আমি একটা এক্সিকিউটেবল ফাইল শেয়ার করেছিলাম, তোমরা কি সেটা দেখেছো?
হ্যাঁ স্যার, দেখেছি স্যার।
Okay. So that should give you some idea about how the program should work.
স্যার ওখানে শুধু মানে আমাকে ভ্যালু পুট করতে হবে, মানে প্রোগ্রামটা তো লেখা ছিল, মানে দেওয়া ছিল না।
না, প্রোগ্রামটা দেওয়া ছিল না, কারণ আমি প্রোগ্রাম শেয়ার করতেও চাই না। ওকে, I need you to write your own program. Number 2 is ওই প্রোগ্রামটাতে যেটা ছিল যে there are many ways one can generate the input data. The XY data can be generated in many ways. You can store in a text file, okay, and it could be read, okay. The other thing could be that you can create a function, okay, some arbitrary functions. For example, I chose some cosine function, okay, actually cos x minus cos 2x.
Yes, cos x, cos 2x. Okay. Yes.
So I deliberately chose an even function, okay, and if you take the x limit from, let's say, minus pi by 2 to plus pi by 2, and once you do a fit, okay, polynomial fit, okay, because it's an even function, and whether a function is even or not, that only matters when you take the symmetric limits. So let's say minus pi by 2 to plus pi by 2. So you'd see that the coefficient of the odd terms, let's say x cube, etc., they become 0 in that one. Anyways, today we would discuss about, or you'd start discussing about solution of a set of, or simultaneous solution of set of linear equations. ওকে, তোমরা কি এই রিলেটেড কোনো মানে ম্যাথসের কোর্সে পড়েছো বা কিছু? হ্যাভ ইউ হার্ড অ্যাবাউট গস, সরি,
লিনিয়ার ইকুয়েশনটা করেছি স্যার।
হ্যাভ ইউ হার্ড অ্যাবাউট গস এলিমিনেশন?
স্যার রিপিট করুন স্যার।
ওকে
স্যার, এই একটু কি একটা টার্ম ইউজ করলেন, ওটা স্যার শুনতে পেলাম না, একটু নেটওয়ার্ক কিছু
শুনতে পেলাম, একটু জোরে বলবেন।
আরেকবার স্যার একটু বলুন।
স্যার বললেন গস এলিমিনেশন।
গস এলিমিনেশন,
হ্যাঁ 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 স্যার।
okay,
Yes sir, yes sir.
then you should be familiar with this. Actually, for some reason তোমাদের সিলেবাসে there is Gauss-Jordan method, not Gauss elimination method, but I would discuss both. Okay, I would discuss both. So imagine these are the variables x1, x2 up to xn. Okay, there are n variables, okay, and you would be given n equations to solve from. Okay, so you have n equations with this n variables, okay, and these are the coefficients. So like c1, sorry, a1 x1 or a11 x1, a12 x2 up to a1n xn equals c1. That is just the first equation. Ith equation looks like this: ai1 x1 plus ai2 x2 up to ain xn equals ci, and then the nth equation is an1 x1 an2 x2 ann xn equals cn. Okay, so in matrix form this could be written as a times x hat equals c hat. Okay, now what is x hat? X hat is, sorry,
আপনি বলুন এ এক্স ট্যাপটা।
হ্যাঁ বলো।
স্যার আরেকবার বলুন, এটা এই যেটা লিখেন এক্স ইকুয়াল টু সি।
হ্যাঁ, মানে এই যে সেট অফ ইকুয়েশন, I'm writing it in a matrix vector format, like writing in a equation in linear algebra. Okay, so this x hat vector is a vector of all your variables, x1, x2 up to xn. Actually, the transpose of that. And same is c hat, which is c1, c2 up to cn. Okay.
Okay, sir.
And A is a matrix whose ijth term is aij, where I is the number of the row, or basically the number of the equation, and j is the number of the variable. Okay, so that is the problem that you are trying to solve in a problem involving a set of linear equations. Okay, and for every method that you would be learning in this way, this case, so today we will discuss about the ones that are called direct methods, kind of the brute force methods. And in the next class we would learn about the indirect method or iterative methods. Okay, so so let's start with Gauss elimination. So now there is one step called partial pivoting, okay, which is a kind of advanced stage. Okay, so you'd skip that for the time being. So what you would be doing is you would be so let's look at this set of equations. So at first you try to remove from each equation the first variable. Okay, so except for the first equation, second equation onwards, we will try to remove the first equation. Okay, through elimination, or we would actually eliminate the first variable. Once that is done, so you would go for the next equation, and for the third equation onwards, you would remove the second variable or eliminate the second variable. Okay. In the end, we would have modified A to another matrix A prime, which would be kind of like only the upper triangle is a non-zero quantities, where the terms in the denominator are terms in the lower triangle are all zeros. Okay, which
স্যার
is
বুঝতে
basically
পারলাম না স্যার, আরেকবার বলবেন মানে এলিমিনেশনটা মানে কিভাবে
yes.
C1 থেকে CI?
So for example, if I define gamma as a I1 divided by A11, okay, and then subtract the first equation, or gamma times the first equation from the ith equation, what would happen to the first term? The first term would essentially be 0. Okay, because once I multiply AI1 divided by A11 with A11, I would get AI1. So this term would be 0. Next term onwards, they would not be 0. So that way, I would be able to eliminate the first variable from the ith equation. Okay, and we need to repeat that process for each and every equation. Okay, and in the end we would have a system of equations which can now be represented through a matrix called A prime. So while doing that, of course, this coefficient vector will change, and this constant vector will change, and also the coefficient matrix, all the terms in the coefficient matrix would also change. Okay. But in the end, we will have a system of equations. Let's say A prime times x hat equals C prime, where A prime is only non-zero at the upper triangle. Okay, and that means on the nth equation there is only one term, which is the a_nn term, or actually in that case it would be A prime nth in the modified matrix. And that way, simply by dividing that modified Cn prime with this ann prime, you would have the nth variable. Okay, and after that you would substitute for the value of that nth variable in the immediate equation above it. Okay, which now would have only two non-zero coefficients. So you would substitute for this value, and then we can evaluate the this quantity xn minus 1, and this thing will proceed. Okay, and how long will it proceed? We will now use a bottom-up approach, and from the bottommost equation to topmost equation we will proceed, and we will be evaluating all the variables in the process one by one. Okay, so in the first phase, in the first step, we would do so let's say we would go for the ith equation. Okay, we would define this coefficient for each j greater than I, and of course j less than equals n. We would define this quantity gamma equals a ji divided by aii, and then we would modify the jth row as for each term. For example, now a for each k where k is greater than equal I, sorry.
Sir, here gamma is a parameter, na?
Gamma would be a parameter.
Okay.
So what you are doing is you are subtracting one equation from the following equations. Okay. So let's say when I equals 1, you have the first equation, you have all the terms. So when you have the first equation, all the terms are non-zero. All the terms are non-zero. Okay. And then what you would do is, let's say for the second equation, okay, for the second equation, you define a, so second equation looks kind of like this. So for the second equation, you define this gamma. and you need to be repeating this process for all the equations. Okay, all the equations that come after the first equation. Let's say we start with the second equation. So for this one, we would divide a21 with a11. So if I am using equation number 1, I'll be taking the first column. If I am at the first row, I'd also be taking the coefficient from the first column, which is a11. So I would define, let's say, gamma for the second row would be a21 divided by a11. And after that, I would multiply this entire equation and subtract from the second equation. Okay.
স্যার লাস্টেরটা কি বললেন? গামা ইকুয়াল টু a21 বাই a11, তারপরে
So after that, from the second equation, I would subtract. So equation 2 minus gamma times equation 1.
Basically, we are trying to omit the first term.
Yes, we are trying to eliminate the first term.
Okay, sir.
Hence the name, Gauss elimination. Once that operation is done, so from the second equation, there is no x1 term. Now we can repeat the process for the third equation, okay, and define our gamma to be a31 divided by a11. Okay, and similarly subtract the first equation from the third equation. So the third equation will also not have the x1 term, and that we would repeat up to the nth equation. So every equation except the first equation will not have the x1 term. Okay, so that way we have eliminated one variable from all the equations except the first one. Then we would move for the second equation. Okay, now the coefficient of the second equation must have changed with all the row eliminations. Okay, so with that modified coefficient, now we would define another gamma. The first one would be a32 divided by a22, and after that we would subtract that equation from all the following equations. Sorry. We will subtract the second equation multiplied with this coefficient and subtract it from the third equation. For the fourth equation, okay, we would again define the coefficient and subtract the second equation. That way we would have removed the second variable from all the equations below the second equation. And the process we will repeat. In the end, we will have only the upper triangle as the non-zero coefficients. Upper triangle of the matrix A would be non-zero. Rest would be, the lower triangle should be 0. Okay. So how many operations are going on? So to eliminate one variable for all equations but one, okay, at first we need to find out, we need to do the row elimination for how many times? J equals I plus 1 to j equals n. Okay, so for ith equation, we must repeat the process of row elimination for j equals I plus 1 to j equals n. So for each j greater than I, or j equal I plus 1 to j less than n, you would first define a coefficient gamma, and then your turn to subtract them from each and every term. Okay, so now before subtracting from each and every term, you can also do this one. You can write Cj, the constant term in the jth row, that can be modified as Cj minus gamma times Ci. Okay, so you basically made this subtraction wherein you subtracted, let's say, C1 times gamma from C2. Okay, and then there is another for loop. please note how many for loops are there. So now so if it is like 1a, then we are going in 1a I. So for each k, for each k now, in the jth row, each k ranging from where? K equals I to k equals n. So basically for each k, so this thing also happens for each I. You see this row elimination, you are only supposed to do n minus 1 times. Once you have done that, you would have got, see, for the nth row, you don't have to subtract the nth row from anything. Okay, so this is how the loop runs. Now for each I, for each k going from I to n, okay, so because you are also need to make this subtraction, right? AJI equals AJI minus gamma times AII, right? You are supposed to do this, right? Once you do that, then what would happen? Since gamma is defined as AJI divided by AII, so the modified AJI would be 0. Okay, so you need to do the subtraction operation for columns going from I to n, and also the constant term. So AJK, the modified AJK would be, after subtraction, would be gamma times AJI. Sorry, not JI. AIK. So you are subtracting ith row multiplied with gamma from the jth row. Okay. Now ideally, the subtraction should happen for k going from 1 to n. But why am I writing it from I to n? Because with all the eliminations that happen before a given I, the coefficients which are smaller than I, for example, a, j, I minus 1, all of those coefficients are already 0. Because you are repeatedly doing all those eliminations, okay? So if your I is like 2, then when you are subtracting or eliminating the second variable from all the equations except for equation number 1 and 2, then by that time the coefficient of x1 has been 0 from all the equations, because you have already eliminated the first variable from all the equations except the first equation. So that's why the loop runs from k equals I to n. Okay, and then okay, এই অবধি কি বোঝা গেল কি হচ্ছে অপারেশনটা?
Yes, sir.
Sir, AGI equals to AGI minus gamma AII equal to 0. Problem হচ্ছে, মানে ঠিক বুঝলাম না ওটা কেন।
আচ্ছা, the thing is গামার ভ্যালুটা দেখো, AJI divided by AII, তুমি গামাটাকে ডিফাইন করছো ওইভাবে।
হ্যাঁ হ্যাঁ,
and that is not changing in the k loop. The value of gamma is not changing in k loop. So even when k equals I, so basically you are modifying the AJI, which now becomes the earlier value of AJI minus gamma times AII. মানে এই যে কে এর যে লুপটা আছে সেখানে কে ইকুয়ালস আই পুট করে দেখো কি দাঁড়ায়, আর সেখানে গামার এক্সপ্রেশনটা সাবস্টিটিউট করে দেখো কি দাঁড়ায়।
AJI equals to AJI minus gamma AII, I think এটাই আসছে।
গামা AII আসছে, এবার গামার এক্সপ্রেশন হচ্ছে AJI ডিভাইডেড বাই AII।
হ্যাঁ হ্যাঁ
তো
আচ্ছা
AJI,
হ্যাঁ হ্যাঁ জিরো হয়ে যাচ্ছে, হ্যাঁ জিরো হয়ে যাচ্ছে,
আচ্ছা
ঠিক আছে।
যদি আমি ফিজিক্যালি ভাবি তাহলে কি হচ্ছে, AJI is the coefficient of ith variable in the jth equation, okay, and I am now trying to eliminate the ith variable from every equation that comes after the ith equation. That's why j goes from I plus 1 to n, okay, so j is actually greater than n. তার মানে you are eliminating, let's say, second variable from third equation onwards, okay, and let's say if j is now the third equation, so you are now trying to eliminate the second term from the third equation, okay. The first term has already been eliminated from the first elimination when I equals 1, when I was equal to 1. Now I equals 2, and this must be from every equation the second term must be eliminated. Okay, now now this is the first phase that gives you the এটা কি বোঝা যাচ্ছে যে that you would get a non-zero upper triangle and zero lower triangle?
Yes sir, yes sir.
এটা বোঝা যাচ্ছে তো? Okay, তো so the next step is to run it in reverse for each I. Okay, so for each I going from n to 1, okay, what you are supposed to do, xi equals ci minus summation over a ij xj, where j goes from n to I plus 1, মানে or it is in this order, I plus 1 to n. এটাকে যদি ভেঙে লিখতে হয় আমরা এরকম ভাবে লিখতে পারি, নাও 2 এর a হচ্ছে for each j, so set s equals 0, sum equals 0, for each j s equals s plus, for each j going from I plus 1 to n, s equals a ij xj, and then once this sum is done, xi equals ci minus or actually I can initiate s as ci and keep on subtracting from s these terms, and in the end I can say xi is s divided by aii. Okay. So now what I am doing, এখন আমার a matrixটা দেখতে হচ্ছে এইরকম, although modified. Now it looks something like this: 0, a22, a2n, then 0, 0, etc. And the last row is only ann. So the row before that is a n minus 1 n and a n minus 1 n minus 1. Terms before that all zeros. So so ধরা যাক আমি এই যে লজিকটা লিখলাম, how is that supposed to be interpreted? And the coefficient vector is something like c1, c2, cn, but these are modified from the originally provided values. Okay, because that way the modification happened, except for the first row every term is modified. Our summation over here, so s starts with ci. So for the first one, when I equals n, we would start with cn, s equals cn, and then there is a loop on I plus 1 to n. Now since I plus 1 would be n plus 1 and that is above n, so there would be no loop on the first one, and that whatever programming language you are using, that it will automatically detect. Okay, once you do that summation from I plus 1, it would automatically detect. So what it would do is for the first one, this subtraction step is skipped. Okay, so it is simply cn divided by ann. Now for the next one, there would be one term that would be subtracted, and that would be an minus 1 times n times xn. There is just one term. Okay, because it has to be I plus 1 to n. Okay, so so now you would substitute the value of xn, the one we just calculated. Now please understand, here the loop runs in reverse. I believe it would look something like this for I equals n minus 1 I.
So we are calculating backwards, right?
Yes, greater than equals 0 and I plus plus. Sorry, I minus minus. Okay. Now, now I hope you understand that for you, every time I'm using n, it would be replaced with n minus 1, and every time I'm using 1, that needs to be replaced with 0. Okay, so that part you need to be careful. Okay, because that's how it works in C. Fortran, of course, would have allowed you to go with n and 1. So I'm not starting the loop with n, but n minus 1, and not ending at 1, but instead ending at 0. So it runs backwards. That's the point. So in this way, we get to calculate the values. Okay. So Gauss elimination process is, I think you have understood, right? এই প্রসেসটা কি বোঝা গেল? কোনো অসুবিধা?
না স্যার।
ওকে, so far we have not introduced partial pivoting. Gauss-Jordan method কি হবে? So what we learned is that if I am working with, let's say, ith equation and I am planning on eliminating the ith variable, I should be doing so from I plus 1th equation onwards, or I should be eliminating that from I plus 1th equation onwards. For example, the first equation or the first row after the entire elimination process has all the variables. Okay, and that's why the substitution is required when you are moving backward from nth equation to first equation. Okay, so when you are going backwards, you are supposed to substitute for nth variable to so you are supposed to substitute the variables that you have just calculated before. So even after elimination, the first equation contains all the variables. Okay, it's because when we move to second equation, we only eliminated the second term from the third equation onwards. When we move to third equation, we only eliminated the third variable from fourth equation onwards. Now, if we do not do that process, if we instead choose to eliminate a given variable from all the equations, okay, so what would happen? So
Sir,
after the বলো
সেকেন্ড ইকুয়েশনের ক্ষেত্রে ইকুয়েশন 2 থেকে মাইনাস হবে আর 3 থেকে?
Now, you'll have to think in this way. Let's say you are trying to eliminate the ith variable. Okay. Then you are supposed to take the ith equation as your base equation. Okay. So that is the equation that you will subtract.
Okay.
And you will subtract that from third equation onwards. As far as Gauss elimination method works, you are supposed to subtract that from the third equation onwards. So third equation onwards will not have the second variable. Okay. Achha. So imagine instead of subtracting only from the equations that come after, if I had also subtracted or eliminated that variable from the equations that came before. Okay. So what would happen? So this A prime matrix that I am saying in a Gauss elimination method becomes an upper triangle matrix. That matrix, do you agree that it would become a diagonal matrix? আমি যদি শুধু নিচের ইকুয়েশনগুলো থেকে এলিমিনেট না করি, যদি উপরের ইকুয়েশনগুলো থেকেও সাবট্রাক্ট করি আর এলিমিনেট করি, do you agree that I'll get a diagonal matrix? এটা কি বোঝা যাচ্ছে?
Sir, can you repeat?
That in Gauss elimination method, we are eliminating a given variable. Okay, let's say the ith variable from I plus 1th equation onwards. So instead of doing that, if I had eliminated that from every equation except the ith equation,
হতে পারে স্যার, তখন তো ট্রায়াঙ্গেলটা চেঞ্জ হয়ে যাবে আই থিংক।
না মানে আমি যদি শুধু নিচের ইকুয়েশনগুলোতে সাবট্রাক্ট না করে উপরের ইকুয়েশনগুলোতেও সাবট্রাক্ট করি, ওকে, সো অর রাদার এলিমিনেট করি, so right now what we have is that in the first equation I have a12 that but once I had if I had eliminated the second variable from the first equation as well, so the coefficient of x2 in the first equation, that would also be 0. So the first and that would apply to every variable and every equation that comes after the second variable. So the first equation will only have the term with the coefficient of x1. Similarly, the second equation will also have the coefficient, a modified version, but a coefficient of only the second term, which is a2. And in that way, we will have a diagonal matrix. The elimination of the first variable in Gauss elimination and Gauss-Jordan are exactly the same. So after the elimination of the first variable, the coefficients in the first column, except for the first row, would all be 0. Okay. But when it comes to Gauss elimination and we move to second equation, in order to eliminate the second variable, we eliminate that from third equation onwards. But if we also eliminate that from the first equation, then the coefficient of the second variable would be 0 in each row except for the second row. And then we go for the third equation. কিছু বললে?
স্যার বলছি ডায়াগোনালটা পাবো তাহলে।
Yes. So in case of the third equation and the third variable, we would subtract or eliminate the variable from every equation except the third equation. Okay. So the process is same. Calculate that gamma coefficient and multiply the equation and subtract each term from a given equation. So earlier we were only doing that to rows that come after. Now we would also do that to rows that come before. And in that way, we'll only have terms, non-zero terms in the diagonal. Okay. So for each I going from 1 to n minus 1, okay, and actually in this case we would not even go for n minus 1. We would do the operation for all the n variables. Okay, for Gauss elimination we only had to do for that elimination operation for n variables. The last equation had the coefficient of that one. A and n, but for Gauss-Jordan elimination, we'll have to do that for all the n variables. For each I, each j, going from 1 to n, if j not equal I, okay, then we would calculate gamma. So you understand, there is a for loop, in that there is a for loop, and then there is a if block, in which what we are doing is calculate gamma as a ji. You need to keep in mind whether it is ji or ij. We are talking about the jth row. So of course it is ji. We are eliminating the ith variable. So the denominator is aii. Okay. And you would first calculate this one, and then first you would modify the constant term. So Cj now would be Cj minus gamma times Ci. And another for loop is there. And that for loop goes for k equals 1 to n. Should it go for 1 to n? Should it go for 1 to n? Actually, it can go from I to n. Okay, ideally it should go from 1 to n, but you can use some smartness to put it from I to n, because for all the variables that came before I, you have already eliminated them from all the equations. But then there are diagonal terms, right? So yes, so you'll have to do it from I to n, 1 to n. A jk equals ajk minus gamma times a ik. Okay, so in that way with this set of loops, okay, and with this check that you are not actually subtracting from the ith row itself. So only for j greater than or less than I that you are doing this operation. Okay, so you need to make this check, and then with this operation you would have this diagonal matrix. And then the second step is to evaluate xi for all I going from 1 to n is simply this: Ci divided by Aii. So this should modify the constant terms as well as the coefficients in that way that you have a diagonal matrix and the constant vector as C1 prime, C2 prime up to Cn prime. Okay, so you simply need to divide each constant term with the diagonal term in the coefficient matrix, and that should simply give you the variable value. Okay.
স্যার পার্শিয়াল পাইভটিং কি আলাদা মানে এর থেকে?
হ্যাঁ, partial pivoting is a different actually it's an augmentation to this direct methods, ঠিক আছে? পার্শিয়াল পিভটিংটা কি জিনিস সেটা একটু পরে বলছি, কিন্তু এই পার্টটা কি বোঝা গেল কি হচ্ছে এখানে? That once you get the diagonal matrix, you can simply divide each term in the constant vector with the corresponding diagonal term and get the value of the coefficient, the value of the variable. So it's like now your modified set of equations are something like this: a11 prime times x1 equals c1 prime, a22 prime x2 times c2 prime. All the other terms are 0. So you simply divide with the coefficients to get the values of the variables. Okay. Achha. Now, be it Gauss elimination method or Gauss-Jordan elimination method, this set of operations that we are doing, okay, so basically what we are doing, we are multiplying a given row, okay, with a given number, given constant number, okay. So we are multiplying the ith row with a given constant and then subtracting from the jth column, okay. So that operation can be written in terms of a matrix multiplication. That can be written like a matrix multiplication. How? So imagine there is a matrix which is and this is your A matrix, which is A11, A12 up to A1n, then A21, A22, A2n, and onwards, and finally AN1, AN2 up to ANN.
AMN হবে মনে হয় সেটটা।
Sorry, ANN.
AMN, yes.
NN.
MN, yes.
And let's say I'm subtracting the first row from the second row multiplied with a constant. So let's say if I take a matrix like this, uh, okay, so this matrix multiplication will keep the first row as it is. So all the other terms are 0. Okay. So if I check, let's say what happens to the first term in the first row, it would be this row times this column right here, and that would be essentially A11. The first term is A in 11. Second term should be again this row, but this column A12. So the first row remains the same. Achha. Now what about the second row? So if I multiply something like this, so it should be, the first term should be A21 minus gamma times A11. Then A22 minus gamma times A12, and so on. So the matrix operation that we are talking about, subtracting a given row or a scaled up version of a given row from an entire row, okay, so that operation right there can be represented in terms of a matrix multiplication. So this, once you multiply this matrix with this matrix right here, the coefficient matrix, it only does this: it subtracts the first row multiplied with gamma from the second row. Every other row remains the same. For example, if you move on to the third row, okay, and let's say this one is A31. So if you multiply the third row with the first column, you get A31. Multiply with the second column, you get A32, and so on. You essentially get the third row of the original matrix. Okay. So every time from each row I'm subtracting another row, that can be represented as a matrix operation. Okay. And every operation that we did can be represented through a series of matrix multiplication on the original coefficient matrix. Okay. Also, for example, in the end, what we can do, so what we did was we obtained this diagonal matrix. We can also convert this diagonal matrix to an identity matrix. So simply by dividing the diagonal terms by themselves, each of the diagonal term by themselves. Okay. So for that also, all I need to do is, let's say I need to multiply this modified A prime matrix with few other matrices. For example, the first one being 1 by A11 prime, then 1 everywhere, and rest as 0. So I can keep on doing this. 1 by A22 prime, and so on. So all of this can be represented as a set of matrix multiplication. So in the end, I would have multiplied a series of matrices, okay, to A to finally get a matrix which is like this identity matrix. We didn't go that far. We only obtained a diagonal matrix, okay, but we could have also gotten that far and finally would have gotten an identity matrix. Okay. Now all of this multiplied, all of these matrices multiplied could also be represented with a single matrix B. Okay, so essentially this B matrix is nothing other than the inverse of A. Okay, now now we calculated this vector of x1, x2, xn. We know that this quantity is essentially A inverse times the vector of the constants. Okay, now by doing all these operations, which are essentially small matrix multiplications, and in the end a cumulative matrix multiplication. Okay, so by doing all of these operations, we have essentially performed this multiplication A inverse over C hat to obtain the values of these variables. The point I'm trying to make here is that using Gauss-Jordan method, we can also calculate the inverse of a matrix. Now, when I tell you about inverse of a matrix, the first thing that comes to your mind that you'll have to calculate the determinant for the giant matrix, then for each of the adjoint matrices and so on. So, so the point is, you might think that this is an n factorial set of operations, calculating a n by n matrix. Okay, and you know how n factorial changes, right? Like 1, 2, 6, 24, then 120, and then it rapidly increases. It increases more than any power of a given variable. But whether it is a Gauss-Jordan method or Gauss elimination method, these methods are the number of calculation of variables. Okay, if you check properly, the number of variables that you calculate, they are essentially, for a very large n, they are essentially proportional to n cube. And by this n cube set of operation, you can also invert a matrix. Okay, so how do you do that? That we will see. That only completes our learning of Gauss-Jordan method. So আচ্ছা, এই পার্ট অবধি বোঝা গেছে তো?
Yes, sir.
Okay. So we would start with two matrices. One is our coefficient matrix, or simply can be written as Aij, individual terms. The other one is an identity matrix, which can be written as delta Ij. This delta is called the Kronecker delta. And delta Ij equals 1 if I equals j, and it is 0.
And 0 if it is I not equal to j.
Otherwise.
Otherwise,
So
yes.
basically, it's a identity matrix. So what we do now is, so instead of performing A inverse over C, we would perform the A inverse over this identity matrix. So this is an identity matrix. We would perform the A inverse on this matrix. Okay. So basically, what we did was, so this was the more or less the algorithm for I equals 1 to n, for j equals 1 to n, I not equal j. We calculated gamma, right? Which is a ji divided by aii. Okay, and then so I'm only writing the modifications that we did. Achha, what I would, so this is an identity matrix, but what I would do is I would initiate a B matrix. Now B is a variable matrix, just like A. So the values of the terms in the A matrix are changing, and values of the terms in the B matrix will also change. It's just that to start with, we would take B as the identity matrix. So for So what did we do next? For K going from 1 to n, we did a jk equals a jk minus gamma times a ik. Aik. Okay. So in addition, if you also start with B matrix, which are in general Bij, and this Bij in the beginning are delta ij. So you also do this operation on Bij. Sorry, Bjk equals Bjk minus Bik. So in the end, you will get a diagonal matrix out of A, and for B also you will get only a diagonal matrix. Why would you get a diagonal matrix? Because to start with, for B you would not get a diagonal matrix. Sorry. Okay. So in the end, the second step is to convert. So we are taking A to an identity matrix, and by doing this operation, set of operation, we would also take B to A inverse. Okay. So how do I get A inverse? So in the end, we would so by doing this set of operation, we will get A as a diagonal matrix. B is no longer a diagonal matrix. B was diagonal matrix in the beginning, but B would not be a diagonal matrix after you have done this set of operation. Remember, this gamma is only calculated from the A matrix. So in the second part, we would divide each row of A matrix with its diagonal term. So for also, we would do the same thing to each row of the B matrix. And then this B matrix would be modified into A inverse. Okay. So we showed that each row manipulation, be it scaling up or scaling down, be it subtracting from any other row or addition, so all of this can be represented in the form of a matrix multiplication, and that way we would be able to solve a given set of equations. Okay. Achha. So that way also we would get A inverse out of B. আচ্ছা, এই অবধি বোঝা গেছে তো A inverse কি করে পাওয়া যাবে? Okay.
স্যার আপনি কি কিছু বলছেন?
প্রেজেন্টেশনটা অফ, এই তো।
প্রেজেন্টেশন অফ হয়ে গেল মানে আমি বুঝতে পারছি না, মানে আমার নেটের অসুবিধা তো এখানে, তাই
না
জন্য
না না
মেবি।
না, ঠিক আছে স্যার, আমার
হ্যাঁ
ঠিক
ঠিক
আছে।
প্রেজেন্টেশন।
আছে স্যারই
So I'm just based on Gauss-Jordan. Okay, I have written one program. So I'm trying to demonstrate that one here. So okay. So let's say it first asks me how many variables I want to solve. So let's say I'm using 3 variables and 3 simultaneous equations. Okay, and what I have done is, and it's not mandatory. Okay, your program can work in a different way, but what I have done is I have stored the coefficients. You see, there would be 12 coefficients, right? So 3 equations, there are 3 variables and 1 constant term in each equation. So there would be 12 coefficients, and I have stored those 12 coefficients in in 3 in a given file. I have stored the coefficients of a given set of equations in a given file. Okay, I have created multiple examples, and that's why I have created multiple files. So that's why I'm asking here the user to provide the name of the file. So currently I'm reading coef2.txt. So I have made about 3 different files with different set of equations. So at first it reads the coefficients and prints them out. Okay. Oh, actually it also does the solution. So the way I have written stored the coefficient matrix in my file is that the first 3 columns would be the coefficient, and then the 4th column is the constant term in that equation. Okay, and it's like is a1x plus a1x1 plus a2x2 plus a3x3 equals c1, or if you want to take it to the left side, minus c1 equals 0. Okay, so that way I have written this, stored this coefficients, and that's how it is reading the coefficient. Okay, and I probably did for this program, I have probably done it in a different way. So just the only difference is the last column of my coefficient matrix is actually the place where I'm storing the constant terms. You need not do that. You can make a separate vector for the constant terms, and your coefficient matrix could be squared and could be containing only the coefficients. So it calculates both. It calculates the AX values, and also it calculates the inverse. Okay. So that is one file. Okay, and I'll actually share these two.
Sir, can you please kindly screen the previous coding, previous the screening, just one time.
Previous string, yeah, sure.
It's one thing I have noticed that.
Okay.
So the previous sum you have done this one. So there I noticed that the x values were 4, minus 3 and 3. So but the matching, the answers are not matching with the equations, I guess, I noticed.
Okay.
Maybe I came wrong, but just I noticed. So I said please take one time.
Okay. So I use this one.
Yes, sir.
Okay. So minus 4 minus 3.5 and then 1. So 4 plus 3 is 7, and then minus 3.5 times 2 equals minus 7. So the total sum is 0. Next equation, 16 plus 7. 16 plus 7 equals 23, and then minus 21, that is equal to 2, and then 4 times 20, then 11 is 31, and then here I am subtracting 28, so 3. Okay. Now one thing, where do we use simultaneous linear equations? How many of you have heard about, or if any of you have heard about something called a finite element method? Is there anyone who have heard about finite element method?
It's hard about it, but
yeah. So I'll explain. See, in structural designing, a lot of times you would be interested in finding out the stresses at different points, or for a given set of load, what are the deflections at different points, and we would discretize the geometry into something called elements. Okay, hence the finite element method. Okay, and the finite element method can also be used for truss structures and other different type of structures. So here I have an example for truss structures.
In material science, I guess this thing is included.
Okay.
Maybe I'm wrong, but I have heard the comment.
Okay. So here is an example of a truss structure, and you see there is quite a bit of trusses involved. And in your first semester, you did engineering mechanics, where you learned about trusses, and you did quite a few problems. You solved quite a few problems, and you did that by hand. By hand, I mean you have drawn free body diagram for either the vertices, or you have taken method of section or method of joint, or you have drawn free body diagram for the individual components and so on. And that way you have answered all the questions that were required to be answered. Now you know that once you write down all the equations, okay, all the equations,
sir, আপনি কি বলতে পারবেন আপনি কি বলছিলেন আরেকবার ফার্স্ট থেকে? So would you please repeat, because I was disconnected due to my internet issue, sir.
Okay, but can you see the screen?
Yes sir, now it's visible.
Okay, so you see here are a number of trusses that are involved in this problem. So I guess there are 8 trusses involved, and you have in your first semester engineering mechanics course solved such problems using hand. You didn't write any computer program to solve this and so on. But in that case, probably a smaller number of variables would be involved, and you are probably asked some tricky questions, maybe like if there are some redundant truss elements and so on. But here maybe you are interested in finding out the forces in each truss, or maybe in this case you are not even considering. Okay, so here it says displacement vector. So here they are considering the trusses are not as rigid bodies, but they are deformable. Now imagine you can do it in both ways. You can figure out what are the forces in each truss member, and then what you can do is you can find out what would be the longitudinal stress, then divide by Young's modulus, determine the strain, and then figure out how much is the deflection. But then with all of that, you would not be able to solve if there is a statically indeterminate problem. If there is a statically indeterminate problem, the only way to solve is to solve the deflection and the equilibrium equation, that is the force equation, simultaneously. And there would be a lot of simultaneous linear equations. Okay, and it would be a difficult problem to solve by hand. And engineers, such as civil engineers, encountered problems like this on a day-to-day basis. And even mechanical engineers employ finite element method and methods like this one, okay, in various other applications. And there also the solution of simultaneous linear equations becomes becomes a requirement. And if you look at how many points there are involved, so there are 1, 2, 3, 4, 5 points are there, of which I believe 4 degrees of freedom. You see, both are pin joined, so 4 degrees of freedom has been constrained. So there are 6 variable degrees of freedom. Okay, so each point could move in x and y, so 2 degrees of freedom each. And then out of that, at node number 1 and node number 4, they have been constrained using pin joint. So 2 degrees of freedom has been constrained. So free degrees of freedom are 6. Okay, so in the end, you will be having 6 equations that you need to solve, 6 simultaneous equations. And you can think of how challenging is that to solve 6 simultaneous equations using hand. I mean, most of you would struggle with 3 equations instead of 2. So you might, and also the number of equations is not fixed. Okay, tomorrow you might encounter a problem where you must solve 10 simultaneous equations. So that's why it is a requirement to come up with numerical methods, come up with programming which would help you solve 10 such simultaneous equations or n number of such simultaneous equations. Okay, so I believe in my program also I have only allowed up to 10 variables or something, so it is also able to solve this 6 unknowns. Okay, so once you work out the math, okay, you get the coefficient matrix, which okay, where is the coefficient matrix? Yeah, this one. So you see the 6 by 6 matrix. This is actually the coefficient matrix. Okay, and what is the constant vector? The constant vector would be this force vector, and you see this quotation sign over here that in MATLAB syntax represents transpose. Those of you who know MATLAB would identify this one. So it is saying that it is a column vector, not a row vector. So this is the vector of coefficients, and this is the vector of constant, and this is the coefficient matrix. And I have incorporated this too in another file. Okay, so I'll show you that even that one you can solve. Okay, so here let's say I would take 6 equations. Okay, and the file in which I have stored it is coef3.txt. Okay, so it is showing those 6 that 6 variable coefficient matrix, and in the right it is showing those force vectors. Okay, apparently only at 2 locations forces were applied, so that's why you see that minus 100 Newton and 50 Newton forces right there. And on the left you see the deflection values calculated, okay, at different nodes, and also the inverse of the matrix is printed over here. Inverse is not always required, but it is only to show you that Gauss-Jordan method allows you to calculate the inverse in the process. I mean, you don't have to do a lot of additional calculations. You're already calculating those coefficients, which can give you the inverse. Okay, so Gauss elimination, of course, cannot do that because it is giving you the upper triangle form. So you cannot do that, but in Gauss-Jordan you can. Okay, so so all I'm trying to show here is can you make a note of all the x values that you have got here? Can any of you take a screenshot or make a note of the values?
Okay, sir. Okay, sir.
Okay, so I want to show you the values that was calculated in that PDF. So I found that PDF over the internet, and those are the deflection values that were calculated. Are they similar? Are they close?
ফার্স্টটা ছিল 0.014607, তারপরটা ছিল -0.104640, তারপরটা ছিল 0.002721, তারপরটা ছিল -0.073073, তারপরটা ছিল 0.005508, তারপরটা ছিল -0.016432.
So they are matching essentially. Of course, there would be difference in your the whether you have taken double precision or single precision. I have declared the variables as real, so they are essentially accurate up to single precision. Okay, I'm not sure with MATLAB by default probably does, I'm not sure, double precision. So this is a PDF that I found over the internet. Okay, this is not related to me. Okay, but I was looking for an example, a practical example of application of solution of simultaneous linear equations. So I came across this one, and as you can see, it calculates very accurately. Okay, so I think I'm done with the Gauss-Jordan method. I only want to discuss the pivoting method after this one, but that is not going to be a part of your assignment or anything for the day. Okay, because what I've found with 3 different examples that I've solved, I'll share the coefficient files. And remember, the coefficients are written like this. The first 3 columns are, or the except for the last column, all the columns are the coefficients, and the last one is the column of the constant vector. Okay, so I'll share 3 files, and you can run your programs using all those 3 files, and you should check that all the 3 files, from all the 3 files that you get correct solutions. Okay, acha arekta ki bolchi, so but what I found was that pivoting, or rather the partial pivoting, is not really important with the example that I chose. So you can skip the pivoting algorithm for the time being. So that would be your assignment, writing the program for Gauss-Jordan method. You don't have to write the program for Gauss elimination. Gauss-Jordan would be your assignment, home assignment, and you can submit that within a week. And for today, your class performance should be to write your a pseudocode for your Gauss-Jordan method. Only a pseudocode for your Gauss-Jordan method. So I more or less wrote the algorithm, so you can come up with the pseudocode. And if you are not confused how to write the pseudocode, you can simply write in the syntax of C program. Okay, that would be fine. Acha. So our last topic for the day. Sorry?
Where to upload this?
I'll share the link.
Okay.
I'll share the link. Okay. Once. So what we will do next is we'll discuss the partial pivoting. Okay, and then our class will be over, and I'll share a link, and in that you can upload up to 3 p.m. Okay. Is that fine?
So for the assignment, so what we have to do, sir, for the assignment?
You have to write the program for Gauss-Jordan method, and I'll share the coefficient files. I'll share 3 coefficient files, and it should be able to solve all the 3. So that is for you to check. Okay. Okay. So okay, let me share the other screen. Okay. So the pivoting method, in whether you are using Gauss elimination or Gauss-Jordan method, first of all, the pivoting method only applies to direct methods. Okay. So in Gauss elimination or Gauss-Jordan method, so what are not direct methods, by the way? They are the iterative methods, in which you'll have to do iterations, and you get a solution after multiple iterations. Okay. Here, when you are using a direct method, the number of the variable calculation is a fixed one. Okay, you need an exact number of calculations. You know that for each row, how many eliminations you are supposed to do, okay, and that after the elimination, how do you calculate the value, so you can exactly figure out how many calculations you are supposed to do. Every multiplication, every addition or subtraction can be thought of as a calculation. How many functions evaluations you are supposed to do, that you can exactly calculate in a direct method. In an iterative method, you always check how much is the improvement or how much is the accuracy of the solution, and based on your tolerance of accuracy, the number of variable calculations or the number of iterations might change. Okay, so that we would discuss in the next class, but in today's class we would end with pivoting method. So pivoting method, so far what we have done is, whatever coefficient matrix have been provided to us, we simply started working with that one. So whatever whatever equation appeared as the first row, we took that one as the first equation and worked our way up to the last equation. Okay. What you can instead do is, before doing this operation, before doing the elimination, let's say you have been given this equation with coefficients a11. I'm only writing the coefficient matrix, sorry, a11, a12 up to a1n. Okay, and then there is a21, a22 up to a2n, and so on. Now, in the partial pivoting method, what do you do is you check for each row. So let's say you have the goal, or you are at a stage of I equal 1. That means your goal is to eliminate first variable from n minus 1 equations. So I'm taking the example of Gauss elimination. Okay, so in Gauss elimination, if you are eliminating ith variable, you eliminate that from n minus I equations. So that is your goal. But which equation should you choose as the equation that you want to subtract? The problem here is actually that if you can choose an arbitrary order, but let's say if you choose an equation in which the very coefficient of the first variable is smaller than the rest of the coefficients, or smaller than the coefficients in the coming rows, okay, you might encounter issues with accuracy. You see, every numerical method is associated with errors, and in this case, the precision matters. Okay, let's say the first coefficient is something like 10 to the power minus 5. Okay, rest of the coefficients are like 2.5, 3, etc. So it's not a good idea to choose that equation for elimination of the first variable. Okay. So in partial pivoting, what you can do is you can search for the rows, because at that, when you are eliminating the first variable, all the equations are unaltered. So in that situation, you need to look for equations. You need to look for that equation or that row which has the highest value of the first coefficient. Whichever row has the highest coefficient of the ith variable, choose that one as the ith row. So basically, let's say the third row has the highest coefficient of the first variable, so interchange between the third and the first row. Okay, and there are a lot of ways to interchange. You might have heard about, so you probably solved the example of bubble sorting and all. So that way you can do, but you need to remember here you need to interchange between an entire row, including the coefficient vector. So now your C3 becomes C1 and C1 becomes C3. Okay, and then let's say the third row has the highest coefficient of the first variable. I mean, there are more rows, but third row has the highest coefficient. Okay, then you interchanged. Okay, and after that you use the usual elimination process of the first variable. Now after elimination of the first variable, the coefficient a22, a32, etc. would change. Okay, basically the new a32, which was earlier like a12, that would change. All of those coefficients would change. Now with those changed coefficients, you need to look for second row onwards. Again, I'm talking in relation to Gauss elimination method, but it also applies to Gauss-Jordan method. Only thing is, when you are doing Gauss-Jordan, you should not only look in the rows that come below, you should also look for the rows that come above. So find out the row which has the highest coefficient of the second variable, and then eliminate that variable. So let's say the fifth row has the highest coefficient of the second variable. So interchange between the fifth and the second row. Okay, and then with the fifth row as the second row, do the elimination operation. Okay, so by highest, I mean the highest absolute value. Let's say one has a value of -1000, okay, and the other one has a value of 0.001. So this 0.001 is not the highest value. This one is the highest value. So whatever is the highest absolute value, that one you should pick for a given row. And that is the partial pivoting operation. Okay, and this can be done very easily in the dynamic way. So before doing elimination of a given variable using a given row, just check whether the coefficient of that variable in that row, okay, is the highest. Okay, so that's the idea. A full pivoting, so this thing is called the partial pivoting. A full pivoting would would have not only interchange of the rows but also interchange of the columns. Now when there is an interchange of columns, you need to understand, not only have you set the first equation as the second equation, that would be row interchange. When you interchange the columns, okay, you have also set, let's say you have interchange between x1 and x3. So your x3 is your new x1. So that you need to keep in mind. So finally, when you, while doing the solution process, there could be a lot of those interchanges. Okay, and when you finally present the solution, you need to have had kept track of how many times you have interchanged and which two variables have you interchanged. So in the end, you should figure out which variable is actually the first variable, which variable is actually the second variable. So people usually avoid the full pivoting method. Okay, so partial pivoting would only have that rows being interchanged, and that has nothing to do with finally you having the values of x1, x2, x3 calculated. I mean, even when in the raw format, when you were given a set of rows, set of equations, you could have called any equation as your first equation. Okay, that doesn't change the order of your variables. Okay, so that's what is in pivoting method. Okay, and this only applies to your direct methods. Okay, okay, so that is the only last thing I wanted to add. If you have any confusion, please let me know. Any question? If there is no question, I hope you understand what is your assignment, which program are you supposed to write, and what is your your class assignment, which is your to write down the pseudo code for the Gauss-Jordan method. Okay, and for that you have time till 3 p.m. Okay, so with that, shall we end the class?
স্যার কোশ্চেনটা আপনি ক্লাসরুমে দিয়ে দেবেন তো?
হ্যাঁ, ক্লাসরুমে আমি দিয়ে দেব।
ওকে স্যার।
ওকে।